Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my Facebook page Chemistry the Mystery of Molecules and YouTube channel TanmoyChem. Today's topic of discussion is actually a very interesting topic and the question is in front of you. Which of the below mentioned compound will not produce carbon dioxide during oxidative ozonolysis? 4 compounds are provided. I request everyone please pause the video, try by yourself and whatever answer you get please write in the comment box along with few words and explanation. I believe you have tried, so let's start now. If you look at this 4 option given and oxidative ozonolysis. So let's learn little bit about oxidative ozonolysis. This is nothing but ozonolysis followed by oxidation. Generally, when we do ozonolysis, we take ozone in carbon tetrachloride as solvent. Now, during this reaction, it produces hydrogen peroxide as a byproduct. What is the problem with H2O2? Means it can result further oxidation. Now, to remove it, generally we use zinc dust water, means zinc water, or sometime we can use dimethyl sulfide because this dimethyl sulfide oxidized into dimethyl sulfoxide, Me2S double bond O. Similarly, triphenyl phosphine, it oxidized to triphenyl phosphine oxide, and in case of zinc, you know, it converted to zinc oxide. So, these way they oxidize and they consume hydrogen peroxide, and this hydrogen peroxide is reduced into water. So, in this way, the produced carbonyl compound, specifically aldehyde, remains safe from further oxidation. Now, you may say, sir, why aldehyde? Why not ketone? See, actually, if you say ketone, oxidation of ketone like acetone is comparatively difficult one. Means during this process, you need to break this CC bond. First of all, it is very inert. Why? Carbon-carbon bonds, two same atom, electronegativity difference is very less. Additionally, this both belongs to the second row element. So, same size, stronger overlap means obviously better overlap results stronger bond. So, this is very difficult to oxidize ketone, and for that purpose even harsh, more vigorous condition needed compared to aldehyde, because in aldehyde case there is a CH bond. So, it is comparatively easier to break, means oxidized into corresponding carboxylic acid. And if you look at the third point, formaldehyde is actually a superaldehyde. Why? Because this is formaldehyde, you can understand that both are hydrogen atoms. So you can say, sir, no plus I plus are available. So the carbonyl carbon is significantly electron deficient or electrophilic. Second thing, no alkyl, aryl, etc. means the bulkness is also minimum. So that's why the nucleophile can attack the carbonyl carbon very efficiently. So both effect combines and make formaldehyde superaldehyde, means very reactive for nucleophilic addition reaction or oxidation, because aldehyde oxidation is easier, CH bond cleavage to carboxylic acid, so it can undergo oxidation very easily. Next, if you oxidize formaldehyde, you get formic acid. By the way, formic acid looks like this. Now, in formic acid, if you look at, there is still one aldehyde group. So, that's why this formic acid can be oxidized further also very easily, and it will be converted into carbon dioxide, where the oxidation state of carbon is +4, means the maximum oxidation state. So, this much knowledge is enough for us. Now let's look at here. So if you do ozonolysis, by the way, there is a shortcut for ozonolysis. Means obviously I'm talking reductive ozonolysis. So here you can think, sir, one oxygen put here, one. By the way, if you have any doubt regarding ozonolysis reaction, I have already uploaded dedicated lecture. You may visit. So I'm going shortcut. So if you do ozonolysis, what you can expect? That's a CH2 double bond O, and this side, this double bond O. By the way, this technique is very helpful because if ozonolysis products are provided in your exam or question, you can just remove this part. Means you can say remove this part, attach this carbon, you can get your parent alkene very easily. Okay, let's come back to our problem. So this is a reductive ozonolysis product, but what was our question? Oxidative ozonolysis means this produced carbonyl compound, we shall check oxidation, possibly not. Actually not carbonyl compound, I shall say specific aldehyde only. By the way, this molecule is formaldehyde. So you may expect, sir, formaldehyde, so its oxidation we should check, yes. So if you oxidize it, you will get formic acid. In formic acid also aldehyde group is present, so you can oxidize it further to get carbon dioxide. Now what was our question? In which of the below mentioned compound will not produce carbon dioxide during oxidative ozonolysis? Now if you look at this side, there was a CH2 which is oxidized to carbon dioxide. this side also CH2. So same logic, it will produce this formaldehyde. Now later on this formaldehyde will further oxidized into formic acid plus 3 oxidation state to carbon dioxide plus 4, same thing. So these will produce carbon dioxide. This will also produce, because if you oxidize, this side one CH2 present, this side one CH2 present. In short, what I want to say, that if it is a terminal alkene, means if there is a CH2 group present, it will oxidize and ultimately produce formic acid, which further oxidation result carbon dioxide. But if you look at this part, this is not terminal alkene, this is an internal alkene. So what you can expect? That's it, this part will be oxidized. Okay, fine. So what do you expect? This part will be glyoxal. And by the way, this part as it is, by the way student, I suggest everyone, please practice, it is very important. And when you deal with such kind of complicated structure or cyclic molecule, check the carbon number. I mean 1 2 3 4 5 6. So this is 1 2 3 4 5 6. So carbon number matches. This is the aldehyde, this is also aldehyde. Now you can say, sir, glyoxal, it is prone to oxidation, I agree. But if it oxidizes, what it will produce? Oxalic acid. But carbon dioxide production is not that much easy, because here also there is a CC bond. So the answer of this question, that CH2 there, carbon dioxide, CH2 there, carbon dioxide, CH2 here, so it will also produce carbon dioxide upon oxidative ozonolysis. So only option C cannot. So in this case, option C is the right answer. Now, if you get this question, what should you keep it in mind? That terminal alkene will produce formic acid upon oxidative ozonolysis, and this formic acid will further oxidize to carbon dioxide. Hope this video may be useful to you. Please write your opinion in the comment box. Thanks for watching. See you in my next video. Bye-bye.